going to run into, you might see that those things have the phenomenon, like those particular bits will have the phenomenon that Peter Gutmann talked about, where the memory specifically has been oxidized in a specific state. So you could do more analysis using this tool, and I thought that was pretty great. I suggested to him that it might be useful to have a motherboard, and for each different electrical type, flash that motherboard with Core Boot, and then you could have a single memory module that Core Boot would use, so you don't even need to modify Core Boot beyond loading the library. And then you can simply take the memory you want to analyze and stick it in the second slot after cooling it. And then you wouldn't stomp on any of the bits, and you could repeat for each different memory chip. And you would be able to sew all of the memory images back together and have an exact memory image that was the last thing that the computer did before you pulled the power. So that's kind of one-upping Bill a little bit, but not by much. But it's really great. And the guy that wrote it, I guess his name is probably pronounced Uwe Hermann, is a guy from the Chaos Computer Club, I think. So he's probably going to talk about this at the 25C3, and if you guys all like Hope and you haven't been to Germany, I highly recommend you come to the Congress. It's definitely the best European event I've ever been to. So I spent a lot of time thinking about countermeasures against all of the tools that I just mentioned, not so much against the previously hypothetical BIOS, but some. And I talked with a number of, I guess, pretty smart people, a lot smarter than I am, about different possible countermeasures. And one of the things that a lot of people really leaned on was the idea of case intrusion, and I think it's bunk. I don't think that case intrusion is really ever going to work, because if they know what kind of case intrusion you have, you can simply raise the bar so they have to hack that before they get to the actual phenomenon that exists with this memory that you have in your machine. There's a paper that someone wrote, it was linked on a Metafilter post about our work, and basically it's the idea that you have sort of like a token-based authentication, like you have like a phone of some sort, and you are sitting next to your laptop, and when you walk away, you have a system daemon that's running, and when your device reaches a certain threshold of a proximity that you think is too far away, then all of the main system memory is encrypted to a key, and it's asymmetrically encrypted to another key, and it's sent to your phone that can then decrypt it. When it gets back in range, there's a very small program that can decrypt the memory that's sitting around, and the phone, of course, has some sort of conversation with the computer, and then it decrypts all the memory, and of course, the whole time that that's happening, everything you were doing on your laptop is like totally frozen, and that's completely awesome research for very specific use cases, but is not so great for everyone else that doesn't have those specific set of not using the internet, not running a server, like a mail server. That wouldn't work for a mail server at all. So it's a creative solution, but it doesn't really actually help, I don't think. And a lot of people would say that this requires physical access, but we live in an era where physical access is pretty much guaranteed to law enforcement. If you've recently read about any of the national security letters that have been handed out to ridiculous numbers of organizations, they include a gag clause, and it's pretty much the most undemocratic thing that I can think of at the moment, and that's saying a lot considering what the Bush administration has done in the last 8 years. But basically, it means that the police can come to your house in the middle of the night because your neighbor called them and said you're a terrorist, and they can analyze all of your computers and never tell you that they were there. And so it seems to me that probably physical access is something that you really can't stop. And these attacks, unfortunately, are sort of a problem. And these utilities hopefully will facilitate research in a direction that will make physical access less interesting when you have, say, you don't have a hardware token. So potentially there are some workarounds, but it's very difficult. So one thing that might be useful, though, is temperature sensors. And at CanSec West this year, Theodore Rate was talking with Bill and I about basically adding in some patches to OpenSSH that would allow you to have support for MAdvise being specifically patched for a kill first bit. So you could say, I want all of these bits of memory to be killed first when someone calls a specific panic function. And that's great, so you can change the threshold of the attack to something like 1 millisecond as opposed to just forever sitting there when an alert happens. But usually you get like a note like, oh, case has been opened. Not so useful. So it's possible that you could have something like that combined with the DDR3 chips that actually have an I2C bus that allows you to set an interrupt and say, like, if the temperature on the chip drops below a certain threshold, throw an interrupt. At least this is what Theo said. I haven't seen one of these chips yet. Throw an interrupt, and then Sensors D can pick it up and say, oh, we have a cooling event that should never occur, and if this has occurred, we're being attacked. And he put a bunch of time into clearing a bunch of arbitrary memory that's just sitting around because he realized you can get it for free. So OpenBSD did take some proactive measures, and that's pretty useful, I think, and maybe someone else will pick them up in the other operating systems that they might use. But measuring different kinds of state change and graphing it over time would probably be useful, and then when you see something that's out of the ordinary, potentially you can do something with it, like react with a kill first bit. But basically nothing is going to be 100% in this type of attack. And you can combine it with other issues. And anyway, these are some of the other things I mentioned. The hardware crypto module is something that's kind of nice. I'm hopeful that someone can convince Hikari to work on a sort of poor man or poor woman's FPGA crypto coprocessor, because it would be nice to have a sort of generic PCMCIA card you could just slide into a laptop, and all the crypto operations take place there, all the keying, everything takes place in that. You know, combine it with a smart card for some sort of authorization, possibly even key storage, and then you would definitely change the attack surface a great deal. The IBM crypto coprocessors are like gigantic things, and you know, you probably can't afford one. I can't. And I went to IBM ZRL in Zurich to talk with them about it, and they said, you know, they thought they could defend pretty well against this, but basically the coprocessor is something that's like very niche market, and it isn't something that's probably going to work out very well for a lot of people. I mean, your software probably won't take advantage of the crypto coprocessor, so it doesn't really matter if you have it. So it will require a substantial amount of work. And of course, it just becomes slightly harder to analyze when you put it in hardware. And I mean, as Karsten Knoll has shown, hardware is not something that is impossible. And in fact, if anything, it will keep out a number of people that might see some things that in their particular domain of knowledge are like obvious bugs, but people that work on hardware might not notice them as obvious bugs. And so it changes, again, who the attacker is and who can pull off this type of thing, but it really isn't a magic solution of any sort. And of course, FlyLogic can rip anything apart, and if there's a problem with hardware, it's done. So anyway, what we'd really like to see, or at least what I'd like to see, is all of you downloading our tools and using them. And if you have time, catalog the memory chips that you're using and the retention times that you see. See if you're using ECC memory, non-ECC memory. There are a couple of other caveats that we mentioned in our paper. And make suggestions for countermeasures so we can sort of like get on with the next iteration of this. Now that it's basically possible to read all of this memory even with the power out on a computer, it should be interesting what people come up with. Of course, if you can't afford liquid nitrogen or you don't have time, you can get a can of canned air. And canned air usually has the chemical tetrafluoroethane in it. And basically, if you turn it upside down, it'll burn your finger. It's cold burn. And if that happens, you can use that on memory, potentially, safely. And it should cool the memory significantly, at least enough for you to transport it to another machine with a core boot BIOS to do the analysis, or enough to specifically set a timer before you set a wake online packet and send it back to do measurements. So if anyone has any questions, I'd like to take some. There's a microphone back there, I think. Kind of nervous, it's Rob,
Don't worry about it. Hello? It would seem the adversary, if you look at you seem to dismiss case switches and case intrusion things too quickly. The adversary is well funded. The adversary needs to spend a lot of money if they built this generic case locking solution that works for everybody. Because of course, if you can study it, you can break it. Given that we are not well funded, but that we all know how this stuff works, we can all build slightly different case intrusion things. And the thing is, if it's a one-off, the adversary doesn't have another case to study to see if they can break it. So the sort of the maker movement approach to case intrusion is, I think in my mind, is actually quite powerful. The fact that it's a one-off is a unique feature.
Absolutely. I think I don't want to dismiss that if you have a lot of outside world inputs and you know what you think that they should be and you measure them, you might be able to find interesting things that are useful to you. But take, for example, I think it's about $250. There's a device that you can use that will sync up with the power of a server, and it also has a UPS built into it. You can also make a vampire tap for the Ethernet cable and basically hook the Ethernet cable into itself so you don't lose link, chop the Ethernet cable, and take that power, the UPS device, and roll the server out of the colo, and basically take that to a place where you have a large vat of liquid nitrogen and pull the power at the exact same second that you drop it into the liquid nitrogen. I don't know how you can defend against that with like one-off case designs. I think that you could defend against someone who is not going to do that, but that attack, for the cold boot attack specifically, I think is, I mean, that's really hard to defend against without having a secure coprocessor. And even a secure coprocessor is only as secure as some arbitrary number that has been pulled out, like $1 million worth of equipment secure. And so I definitely think for most people, what you suggest is a good idea, but it's... A Mercury switch is a good idea. I like that. It's possible. Your one-off is probably going to be better than almost everyone else's, Rob. Let's face it.
What has been the single best either hardware or software implementation for resisting this attack that you've seen so far?
Well, there really isn't any. I mean, to be more specific, you can set a BIOS password on your machine, and that way when someone does your attack, they can also read your they can also read your BIOS password. Yes, Paul.
So, hi, Jake. As you know, I work on some software that regularly reads RSA keys for many people probably here in the audience. So my first question is, what can programmers do to mitigate some of this attack, seeing the constraints of having to read these keys and having to use them? And my second question is, I hope my RSA key is sort of like indistinguishable from like a random bit of memory. So how do your tools actually find RSA keys compared to def random?
Very carefully is the short answer. So in the case of being a developer and needing to use RSA keys, I really think that since you're using main system memory that has this phenomenon, you're kind of in trouble. I mean, if the key is unencrypted in memory, everybody knows if you root a box and you have access to the kernel, you can read out all sorts of arbitrary memory. It's nothing special. There's nothing new about that. It's basically just the transformation of that into the off state. And so I don't know how you're going to really... I mean, so, okay, a couple of people have suggested obfuscating. Who here believes that security through obscurity works out? Raise your hand. Hey, we have one guy in the back. Excellent. If you wanted to, you could put your keys in a specific part of the lower boundary of memory that is constantly initialized by your particular proprietary BIOS. And I think that would be a possibility, but I don't think that, I guess I don't think that that's really, I don't think that that's a great solution, especially if you write free software and someone like realizes that they're attacking, say, a particular free software project that has that countermeasure enabled. I mean, if everybody's doing different countermeasures, it'll make it harder for the analyst. And I support making it harder for the analyst. So go for it. But I don't think that you should think that it'll be a good solution. Like, I mean, keeping keying information in a cache line on a CPU might be a better idea, but that's like a fixed amount of space. Putting it in registers could be a fixed amount of space. So, yeah, and the person that wrote the RSA key finder will tell you about how it works. This is Nadia.
Hi, everybody. Can you hear me? Okay, so the way that we recognize keys in memory is by looking for the structure that the keys are stored. So with AES keys, it happens that everybody stores a key schedule of all the round keys in the same order in the exact same way. So if you want to hide your AES keys, break up the key schedule in some way, maybe it's still predictable, but it'll still be harder to do than we can do it already. And if you want to hide RSA keys